Hello, guys. Welcome to the second episode. Let's take a recap of the first video we have talked about. In the first video, we talked about what is an algorithm, what are the basic requirements of an algorithm, and we also discussed about an algorithm of how to make a tea. Now, as you can see that the inputs for the making a tea were milk, water, tea leaves, utensil. We need heat as in gas or stove, and sugar. Another input that might comes in making a tea is number of people, number of guests for whom we are making the tea, and output was tea. Now, in this episode or in this video, we'll talk about different properties of an algorithm. There are different ways to achieve the same thing, right? If you're going from your home to school, you might take different paths. Someday you want to take the path via the park, and someday you want to take path which is the shortest one. Someday you are with your friend and you have enough time to spare, so you take the longest path just to have fun with your friends. Similarly, in computer science, the same output from the same input most of the time can be achieved via different paths, or we call it different algorithms. Properties of an algorithm help us to compare different algorithms. Now, if we are comparing algorithm 1 to algorithm 2, there must be something in order to compare both, right? So that they are distinguished apart from their steps. These are the objective properties of the algorithm. Most of the time we just need to find the fastest way to get the output. So in example, if you are going to school in the morning, you always want to take the fastest way. You don't want to have fun with your friends, talk and waste time. Most of the time you just want to reach fast before the morning bell, before the first class. But while returning, you might take the longest path because you just want to have fun. So sometimes we are ready to not use the fastest way also because we do not have enough space. But that is like because of other constraints, we don't want to take the fastest way. For example, if you're going from home to school, but the fastest way is filled with traffic or something, or the fastest way is filled with maybe there are some potholes and everything, and you don't want to take that. So you take the smoother road, even though it is not the fastest one. So let's understand the properties of algorithm with an example. Like we have added another input hour in our tea making algorithm, which is the number of guests to serve. Assume that for the 5 minutes we have put it into the gas stove, we have waited for 5 minutes here. This is for like 10 guests. Normal small utensil will be able to handle it. But you are having a restaurant. Sometimes you have 100 people who want tea at the same time. Sometimes you have 1,000 people, and sometimes you have 10,000 people in order who wants to have tea at the same time, and you need to prepare it. So my next question is, what changes are needed in the tea making algorithm? Assuming that the time taken for 10 guests was 5 minutes. Okay, so suppose there are 100 people. Maybe we need to increase the utensil size. We increase the utensil size and we heat it for. Now, if you have increased the utensil size, it's going to take some more time to prepare the tea, right? In the 5 minutes the tea will not be prepared because now the quantity of milk, the quantity of water, the quantity of tea leaves, sugar, etc. are more. So assume that we need to heat it for 10 minutes. Now what happens if 1,000 people comes in? Again we will increase the utensil size, and we heat it for, let's say, 20 minutes. Now 10,000 people come. The problem with 10,000 people is you will have the first idea that okay, we can increase the utensil size and just prepare it for 10,000 people. But the problem is the utensil size is limited. Suppose in the world the maximum utensil size you get is a utensil which is enough to prepare for 1,000 people. Maybe in the future we will have a utensil which can serve 10,000 people or prepare tea for 10,000 people at the same time. But right now in the physical world that we live in, it's not possible. So you can't increase the utensil size. In this case, repeat 10 times steps to prepare tea for 1,000 people. So now we have the same algorithm, but we the number of people has changed, and because of that, we have to change the utensil size and the amount of time that we are taking to prepare the tea. So in this case, you can see that there are two major properties that are coming out for the algorithm, and that so now here let's just recap a little bit back. The time taken for 10,000 people becomes 10 into time taken for 100,000 people, which is equal to 10 into 20, that's 200 minutes. So as you can see, the difference between the difference in the algorithm for the three people that for the three scenarios is the time taken as well as the utensil size. So those things defines the properties of an algorithm, which is time taken by the algorithm, and let's say space taken by the algorithm. In the tea making algorithm, we have the space taken, which is utensil, and time is your cooking time or heating time. So majority of the time we have these two important properties of an algorithm, the time taken and the space taken by the algorithm. Again, space taken means in this term it is the utensil size, because bigger the utensil size, bigger space it will take. Similarly, in computer science, when you when we match it to 101, it is that space that is in the memory that the algorithm takes. Time is the number of CPU cycles in seconds that the algorithm takes. That is the CPU cycles. So when you ask what a CPU cycle is, nothing is, it's in one CPU cycle, CPU mostly execute one instructions, and we need so that is where time comes in, and that is important to know the efficiency of the algorithm, because you don't want to run an algorithm for thousands of years, because it's not needed. It will become useless. So you want to reduce the time taken by the algorithm, but sometimes you are bounded by the space taken by the algorithm. In the 10,000 people case, we could have done it in, let's say, 40 minutes, because as we are increasing with a factor of 10 in the number of people, the heating size was becoming twice. So if we had big enough utensil for 10,000 people, it would have taken 40 minutes, because every factor of 10 in the number of people are increasing. We are assuming that it takes twice the number of time from the previous scenario. But we can't do it in 40 minutes because of the current scenario where the utensil size is limited. So that same thing happens in the algorithm. Sometimes there are faster algorithms, but because of the restrictions in the memory sizes and the data structures that you can use, you can't take so you can't use the fastest algorithm. So there comes a trade-off. We call is the time space trade-off. So here in this particular scenario, we did a time space trade-off by looking at the fact that we repeated the steps for 1,000 people 20 times because of the limitations of the size of the utensil. Now, in algorithmic terms, in computer science terms, the time taken by the algorithm is called the time complexity. We have special notations to denote the time complexity, which is O notation, theta notation, and sigma notation. And same notations are used for space complexity as well. We call this is just a term we use to define because we need just in mathematics how you need symbols to identify some properties of mathematics. For example, if you have 5 bars, you say use symbol 5 to denote that you have 5 chocolate bars. Similarly, we need some sort of symbols, mathematical symbols, to denote the complexity, alphanumeric symbols. So we are using O notation, theta notation, sigma notations to define the time complexity and the space complexity. We'll be explaining the time-space complexity in details in the following videos, but in this video we are just explaining that the two major properties of an algorithm are the time complexity and the space complexity. That is the time the algorithm will take and the space, the amount of memory, anything that the algorithm takes. Okay, that's it for this video. I hope you had a great learning experience. If you guys have any doubt, please comment and please do like and subscribe.